Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT One, the consultancy that helps companies create value from data to accelerate growth. And our guest today is Daniel Young, Senior Manager of Product Standards at Toshiba. Toshiba has contributed to a sustainable future by applying innovative technologies to value creation for over 140 years. And in this talk, we discuss the state of manufacturing in America, trends in manufacturing technology adoption, and the remaining challenges to address. We also explored the role of standards and microservices in enabling solutions to be integrated and deployed with significantly lower system integration costs and timelines. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, you can email us at team@iot1.com. Finally, if you have an IoT research strategy or training initiative that you'd like to discuss, please email me directly at erik.walenza@iot1.com. Thank you.
Daniel, thanks for joining us on the podcast today.
Hi, thanks, Eric. I'm happy to be here.
So, Daniel, I'm really looking forward to the conversation, and maybe I'm looking forward to this first part of the conversation where I get to ask you for a status update on the Industry IoT Consortium, the IIC.
Right.
We were chatting before we kicked off here, and I was just telling you that I used to be quite involved in the IIC, and now I've been trapped in China for 3 years, so I haven't been as involved as I would like. But I know that you're on the steering committee, so would love to hear a little bit more about yourself and also hear the work that you're doing with the IIC these days.
Yeah, well, great. Well, first off, I'm glad that you got the name change. Probably when you were involved, it was the Industrial IoT, and now we've had the name change, so it's Industry IoT Consortium, and that's to reflect a broader scope of different business objectives and vertical markets. But so for my case, I've been with Toshiba for over 20 years now. So I've got my background is in electrical engineering, but I've worked in manufacturing, test equipment design, software quality assurance, and for the past 10 years or so, I've gotten involved in different standards organization and consortia, such as the IIC. So currently, I work with our Toshiba's Digital Innovation Technology Center, and what we do is we promote best practices, whether that's standards, organizations like the IIC, promoting industrial IoT systems, and our reference architecture, which is based on the IIC's IIRA, Industrial IoT Reference Architecture. A lot of acronyms. So.
How would you classify the IIC in terms of, I guess to some extent it's a standard setting body, but it's not setting kind of the technical standards that are dictating how data is transferred, for example. It's more setting kind of, these business architecture concepts for best practices and so forth. But how do you look at the IIC's role in this ecosystem?
That's a great way to put it. Yeah. So we're not a standard setting body, but we promote, best practices, including standards. So, and we do that through a variety of things. We have the core fundamental documents like the reference architecture. We have a connectivity framework document that was recently updated, networking framework, and a security framework. So we do those as core documents and promote, different standards that are internationally accepted. And we also work with these standards bodies where there are needs. So maybe there's not a standard for a particular area. So we might work with a standards body, whether it's OMG, which is the parent company, or IIC, ITU, et cetera, to kind of, see if there's a larger need for that. The other thing we do is test beds and test drives, so real-world situations. Currently, we have a over-the-air updates for automotive or any type of transportation type vehicle, whether it's a robot in a factory or a car. Yeah. So and then we work with best practices in digital transformation. That's one of our new up and coming things where we're looking at companies and how they're transforming themselves and what are the things that they're doing. What are they doing, and what is helping them achieve those goals? So there's a lot of standards out there that are helpful with that.
Yeah, and yourself, are you more focused internally on Toshiba, the organization, and helping the different functions and business units understand the standards and best practices and kind of comply to them? Or are you more focused on helping to represent Toshiba's interests to the standards bodies and participating in steering the standards of the future?
So a little bit of both, but more of the latter, promoting certain standards, helping develop them. And then, like with the IIC, is promoting the ones that we use internally that we find useful, and promoting that, outside of our organization.
Okay, gotcha. And maybe this is a good jump off point to start talking about the state of the industry today. I mean, standards is maybe not the sexiest topic, but it's an important one, right? So,
right.
Where are we with standards? Because obviously, we're coming from a legacy where everybody had their own kind of proprietary protocols, and we're, hopefully moving in a direction that's a little bit more similar to the consumer internet, where you have, very universally adopted standards. We probably won't end up quite there, but where would you say we are today in terms of having standards that allow companies to play nicely with each other when they're integrating solutions?
So I think there are a lot of standards that exist that help with that, and I would note like OPC UA is a very very well known, and it is helping, like in our UPS business. OPC UA is being used to communicate different UPS vendors, so we can use services that originally worked with our UPS, and now it can work with competitors because of a standard like that. I think where there is lacking, and that's a big topic with all types of organizations, including the IIC, is accurately representing certain types of data models and having this ontology of equipment capabilities. So that's going to take a lot of time, and it's kind of spread out between these different vertical markets, whether it's building smart buildings or in the energy domain, a factory or a electric generator. But there's a lot of common parts to these, and it's just going to take some time to see where that overlap is.
So help me understand that in a little bit more depth. Is it like if I'm talking about steel, for example, then we can very precisely define different grades of steel and what differentiates one from another. But if I'm talking about two pieces of equipment and they both have some kind of predictive maintenance solution, it's hard to compare those two and say why one might be superior. Are we kind of looking at it in that perspective, or how would you view the challenge here?
Yeah, a little bit. Or, like not understanding the full set of capabilities that each device has. And maybe one vendor calls it something different than another vendor does. I'd try to use it like a good example is like a temperature sensor. It could be a temperature sensor and it just has temperature, but most temperature sensors also have humidity. So, do you need the humidity control or not? Some might, some might not, but you need to have that as part of that capability description. And so that that's a really simple example, but extend that out to other types of equipment where you have just those very small, seemingly insignificant differences, but they actually cause big problems when you're trying to maybe a vendor wants to change from one set of software to another, and those type of differences make incompatibilities that you then have to deal with, and that gets into the system integration issues. And one of the things that Toshiba is trying to do is minimize that amount of system integration, and standards play a huge role in that.
Is software also included in here when you're talking about kind of aligning ways of communicating capabilities? Because if I look at product categories, the IoT platform is probably the most challenging product category to compare three and say, here's why A, B, C are different from each other. I mean, you have marketing teams that are just kind of throwing out bullet point lists of functionality, but understanding what they're really capable of, it seems very difficult until you actually do a pilot. And by that point, you've invested a tremendous amount of effort into the assessment.
Right. Yeah, that's a huge challenge today. I think especially for like cloud adoption, it makes it a little bit easier as we start to have newer tools that can dynamically switch between a cloud provider. So, example, we use Terraform scripts that allow us to move from one cloud provider, say it's Azure, over to AWS, or it used to be Google, but now that's gone. So those type of tools help. But you can automate some of that system integration, but you can't automate all of it. So there's still some pain points on that front.
Yeah, I've seen some stats. I mean, you never know how much to trust them, but the one I saw and recalling is system integration being something like 30-40% of the cost of a typical solution, right? So that's a lot of, let's say, fat to trim. I mean, it's work that needs to get done, but in the end, it's not necessarily value-added work if you can accomplish the goal without that.
Right. And I think this newer trend, it's maybe not new to IoT, but it is to industrial, is the use of microservices that are allowing this more modularization of components, so that system integration still exists, but it's a lot easier than it used to be, because now you can fit these modular components together instead of trying to rebuild a monolithic piece of software.
Before we get maybe more into detail around technology deployments and so forth, and I'd like to pick your brain a bit on the state of manufacturing in the U.S., because I'm sitting here in China. I'm American originally, and it's a topic that is always, I'm always reading about it and so forth. And now I have the chance to pick the brain of an engineer sitting in, I think you're in Nashville. Is that right?
That's right.
Okay, great. Yeah. So
you caught the accent.
So yeah, we'd love to understand. I mean, obviously we have on the one hand a lot of labor shortages and some challenges here, which are also kind of an impetus to invest in automation and technology. You also have some degree of reshoring. How would you characterize the state of manufacturing in the U.S. today?
I think it's the wild, wild west in a lot of ways. The big challenge is the brownfield scenarios. If you're building a brand new plant, then you can use all these latest tools and technologies, no problem, because you have nothing. You're starting from scratch. But it's the existing plants and operational facilities that are struggling to update or even see the need to update. Biggest challenge we see right now, especially with cloud adoption, is just data privacy. Who controls that data? Trustworthiness issues of the the vendor or the cloud service provider. Those are really big challenges.
Yeah. So this data privacy issue, is that more from? Is it an individual privacy issue, as it might be more in Europe, or is it more of a which company owns the data and more of a leverage position relative to vendors and manufacturers?
Yeah, what I'm seeing in our U.S. Businesses is the latter. It's the businesses very reticent to share their data, not necessarily with a company like Toshiba. If we have a good working relationship, that's not the issue, but it's delivering that data to the cloud, right? So that's where a lot of that reticence comes in. So especially dealing with if we get into like artificial intelligence models, we really have to do a better job of communicating exactly what it is we're sharing to the cloud to allow these AI engines to work. So maybe we don't need, we're not transmitting all of your raw data. We're just transmitting some of the parameters that the AI model needs. So it comes down to, it's not a technology roadblock, it's a human understanding. And we all need to do a better job of communicating what it is what it is we're trying to do and what type of data is needed to do that job.
Yeah. Yeah. No, this trust issue is interesting. We were doing a project for Siemens recently, helping them, one of their businesses, figure out their AI strategy for manufacturing. And one of the things that we were looking at is you have all these technology startups that have pretty interesting solutions and are trying to go into the market. But then, they're trying to convince a customer to be, you're going to be our customer number 6, right? And nobody wants to be customer number 6. They want to be customer number 600 because they're going to be giving you a lot of data, sensitive operational data. And you're a company that has 50 employees and has been around for 3 years and could be bought out, could be bankrupt, could be whoever. And so looking at the, kind of the opportunities between a large company like a Toshiba to help to bring some of these technologies to market because you have the established trusting relationships. Is that part of your portfolio? Do you kind of play that? It's not really a gatekeeper role, but it's more of like a coordinator role or an integrator role. Is that something that Toshiba also does?
Yeah, definitely. I think that's one of our key strengths is we have these existing relationships, and as we change, our technology portfolio. So we're in this process of changing from a product oriented hardware based company into this as a service, services based. That helps us immensely because we can go to existing customers and talk about what it is we want to do and prove it out, proof of concept, and then get that engagement, and maybe there's changes that they want to make, but those are enabled by a very close business relationship.
For the dynamic in the U.S. right now, you said it's a bit Wild West, but there's very prominent labor crunch that I read about every day in the Wall Street Journal. How is that impacting the adoption of technology? Is that, I guess on the one hand, it means, you only have so many engineers available to actually deploy new solutions, right? So you need actually IT talent, and maybe a lot of mid-sized factories just don't have, that level of talent to manage and deploy. On the other hand, you have shortages, on the factory floor that are probably incentivizing more automation. How do you see that dynamic interacting with technology investments?
So there's several fronts on that. Kind of working them back, the labor shortage on the manufacturing side, that's where we're seeing our technology being used not just to augment capabilities, and not necessarily to make it completely automated, but to enable those workers to do the type of tasks that only a human can do really well. And we're also seeing that we can turn around and offer those services as training models. So we can do training with new employees that is much less, doesn't require as much of the veteran staff to do that training, because you have these new digital tools that can look at the real world situation going on in the plant and help train those new staff. Then on the technology front, as far as the engineers and such, that's always a concern. But I know for Toshiba, we've been hiring hundreds of AI engineers over the past few years. So hopefully we're getting up, we're keeping ahead of the curve in that game at least.
Yeah, I got it. Yeah, it's a bit of an arms race, right? Accumulating talent right now. If you look at, maybe we just look at this from Toshiba's perspective, but what are the technologies that you're seeing, I guess, and, industrial never really hits that hockey stick where something just takes off, but what are the ones where you see starting to get enough broad adoption where people are moving beyond pilots and kind of are quite comfortable now scaling into more national or global deployments?
So I see two things. One is the remote maintenance and predictive maintenance tools, and that kind of spreads out into basic, alarm type stuff, but getting more so into, well, what's actually causing this problem, and can we predict it in advance? So can we predict a motor failure such that I could tell you, hey, your motor's going to fail within a year's time. So go ahead and plan ahead to have it maintenanced or have it replaced. We see that as a huge benefit and something that customers really like. And the other is visual inspection processes. So automated visual inspection is something that Toshiba's been working very hard with, and we're seeing a huge amount of applications on that, whether it's monitoring, meters in an existing plant that are, you've got all these dials and indicators that usually a human has to walk around and look at. We're seeing applications where we can use cameras and robots with cameras on them to go and monitor that using image recognition and then we also I have a case study I can talk about in the steel inspection industry where we're using more advanced image acquisition and processing to actually measure particles in steel samples.
Oh, interesting. Yeah, let's get into that. So particles in steel samples, what is that? Is that measuring impurities or?
Right, measuring impurities. You think of the scale that comes off when you're melting metal, and you have to clean that off. Well, some of that microscopic still gets into the samples. So there are different regulatory and standards processes for measuring those little. They're called non-metallic inclusions. So we measure those, and they can be down at the sub-micron level. But generally, those get measured, and that allows a grading of the steel for its quality. So think of like structural steel, building bridges and other buildings. You want much stronger steel. So that grading process in the past has been very manual. You have a very well-trained inspector who is looking through a microscope, and maybe they do have tools, image processing tools to help them autofocus and such. But at the end of the day, they're actually looking with their eyeball and measuring these very, very small inclusions, and then performing a grading process of what the quality of steel is.
Okay, interesting. I mean, both of these are interesting cases because they're applications of machine learning where you have a training cost, right? And each situation is a little bit different. And so if you have to do the training, for each unique situation, then you have the high upfront cost. But as kind of the algorithms improve and the data tagging processes improve and so forth, then you can bring those costs down. I'm actually just personally very curious in this because we're working on a similar project, also machine vision in automotive, but we're kind of trying to figure out what the cost structure might look like because we're at the very early stages, and you're trying to think, are we going to be able to get to a reasonable accuracy level within a reasonable investment, or are we going to find that we, by the time we are starting to approach that, we're already way over budget. So how do you, maybe you can talk about where we are and how do you optimize that process or kind of assess that to make sure that you're addressing a use case that's really financially viable?
Yeah, so in this case, this is kind of all the combinations we're talking about with labor shortages and such. So, steel inspection it's very highly trained. You have to be a very highly trained to do this. So you can imagine with labor shortages, and you don't have a lot of trained inspectors to do this. But on the other hand, for these type of measurements and the regulatory requirements, you need a human inspector to give that judgment. So you can't just automate that process, right? So what we looked at doing is, well, okay, we know that we're going to have a human inspector performing this grading. So what can we do to assist them? What can we do to take away all the rote work from that? So let's automate the microscope, the autofocusing. Let's do all these things that the inspector usually had to do and takes a lot of time to do. These processes, this inspection can take upwards of like 4 to 5 minutes per sample, right? So, and I think a good idea is like, you think of a camera. In the old days, you had to focus the camera and change the f-stop and all that stuff. And now you can just pull out your phone and click, right? Is the point of taking a picture changing all those parameters, or is it to capture the image that you want to capture? So in this case, we focused on, well, we need the inspector to actually have the image ready and be able to make these measurements, and maybe do some of them for them. So the AI tool, the training part, is looking at these non-metallic inclusions, and we got that up to about a 90% accuracy of measurement sizes. And that's down to like sub-micron level. So what that does is that takes a lot of the burden away from the inspector for, let's say, the easy inclusions, and lets them concentrate more on the very difficult ones. And so that ended up we can take a 5-minute process down to 1 minute by just doing those things. So automating the rote work of that inspection process. But at the end of the day, it's still the human inspector that provides that final judgment.
Gotcha. Okay, that sounds like a smart approach here, dealing with the same existing process, existing infrastructure, but automating these more labor-intensive steps. Yeah. What about in terms of robotics, 3D printing? Are you seeing any other, maybe IoT platforms? I guess you've touched on a little bit already. Digital twins, edge computing, anything else that you're seeing starting to kind of move beyond this kind of pilot phase more towards wider deployment in the industry?
I've seen research in our Bristol labs on swarm robotics. So taking factory floor space, taking robots that can move equipment around or move stock around, and when the stock gets too big, then the robots can merge together and pick up larger objects and move that around unassisted. So I think, and that's maybe more of a greenfield application, but I think that's going to be very powerful in the future. Other, going back to machine vision, I think there's a huge question. It used to be where is the edge? Where is the edge located? And we had that idea of fog computing. I think now we're seeing that in the AI realm of where is the AI? Is it in the cloud? Is it at the edge, or is it on the device? So we have some video processing chip Visconti that's being used with one of our partners, LabForge out of Canada. And they're using the deep neural network capabilities of that chip in their smart cameras. And they can put multiple cameras out in a location and map an entire area using very low power, using solar power in many cases. And all the AI is running on the camera itself. It's not running in the cloud. All that's being transmitted to the cloud are the mapping data points. So very low power, very low network bandwidth needed. I think that's really interesting, and it's going to open up a lot of use cases for drone security, mapping, securing physical locations and such.
Yeah. No, there's incredible amount of innovation going into this space and at different layers, right? I think we had maybe 6 months or so an Israeli company on that was designing chips specifically for machine vision applications, and just a small company and just making their contribution. But you see at each level of the tech stack, they're moving this forward because it's such a practical application. You mentioned earlier dark factories. I'm curious because this is kind of very much a standards topic. If you're going to have a dark factory, you better have some pretty good standards. And it's a topic I've been hearing a lot more about in China lately. And sometimes I feel like China, maybe they read McKinsey reports a little bit too diligently and get a bit excited, a few years before they should. Do you see that as a viable kind of a viable manufacturing approach aside from maybe a few extreme cases in the coming years? Or do you think that's still, it still makes more sense to kind of pick and choose your use cases, but not disrupt processes so much? Where do you see that particular topic?
I think as we look at factories and we need to be more mindful of what it is they're trying to do and come from a more user focused mindset instead of a product focus. What can I put in your factory to make it better, and think more about what are your existing processes and existing problems, and how can I facilitate that. And if that means, completely automating some task away, then okay, but that's not necessarily, applicable for every factory. But yeah, I really don't have a good question for that. Good answer for that. That's a big topic.
Yeah. Well, I think that is probably the right approach, right? And it's a difficult approach for somebody who's selling technology, right? Because then
right.
Your goal is to sell the technology.
Yeah. So to come in and tell someone, well, I don't need to. Your equipment is fast enough. You don't need a bigger processor and more memory. What you need is a better algorithm. And that's what we're seeing today in a lot of cases is we can improve algorithms. We can use AI models to do things that in the past was, well, we have to go shut your plant down for 2 weeks and install a bunch of new equipment. But that's the benefit now is that I don't have to shut your equipment down. We can upload new software. If it's in the cloud, then there's no downtime whatsoever. So that's a huge benefit for customers once they understand that.
Yeah, absolutely. Especially, in the U.S., a lot of the factories are a lot of the equipment's a decade old, a couple decades old. So you're dealing with these legacy environments. Maybe we can touch quickly as kind of a wrap up here on some of the challenges that you see in terms of deployment, and if you have any insights around how to address those. You've already discussed this related to kind of data ownership, data access. If you look at it from a technical standpoint, organizational, defining the business case, setting the standards, are there any others that jump out at you as really common challenges that still lack great solutions in industrial automation or digitalization? Or where would you say that you're sweating the most when you're planning a new deployment?
Sweating the most. That's so. I think one of the challenges, like a company like Toshiba has, is we're very strong technical focus. So, like in predictive maintenance applications, what we see is we're going to customers and we show them, what we have, what we can do, and they say that's great, but it's overkill. I don't need to know that a bearing is failing in the motor. I need to know that the motor is failing, and when should I replace it? So what we're trying to do is back off and say, okay, we need to have granularity between what the customer actually needs. So for some plants that don't have highly enough staff to really get down and say, well, I can replace a bearing in a motor. Well, okay, we just need to let them know you have a motor failing. For another customer that's much more maybe advanced in that, they might want to know a more detailed analysis of why a piece of equipment is failing, and then we can get even more granular with that and start predicting when some part of a piece of equipment is going to fail, so that customer can plan ahead. So that's a challenge for us, is to learn what the customer actually needs, how granular do they need it, and how much information do they need to know, because sometimes they don't need to know as much as we think they do.
Yeah, that's a great thought. We also do a lot of work in Germany, and you have this trend there where these companies have teams of people that have worked for them for 20 years and have just a very intuitive understanding of the process and a tremendous amount of experience. And this generation is to some extent retiring, and then you're maybe bringing in somebody from Turkey, from Poland, so somebody who's relatively young who lacks that experience, and that they need to be quickly up to speed. And so it's, do you have the right interface? Are things to some extent simple enough and the right level of complexity, and that somebody can plug themselves into this system?
And so, as going back to the metal industry case, as we deployed this new update of our product, we realized at in the middle or at the end is like, well, these people are still having a problem with trained inspectors. And although we're alleviating the workload on the veteran inspectors, we're not doing anything to help these new inspectors get up to speed, right? So we looked at the AI model we had developed, and we said, hey, this is a training model. We can turn this around and, take real world data and train these new inspectors on it. And because the AI model is always, can always be updated, and we always have new data sets, we can continually train these people with, real world up to date image samples in this case. So I think that's another kind of revelation that we have, is we have the power to train these new inspectors. We have the data available. We just need to think about what's the best way to approach, to train these new staff.
Yeah, that's a very interesting way of looking at this asset that you've built up, right? That the work can flow in both directions to some extent.
Right. Yeah.
Yeah, cool. Well, anything else? I guess we've touched on a bit about the situation in the U.S., technology adoption challenges. Anything else that you're seeing that you think is particularly interesting in manufacturing in the U.S. today?
I think the other part, and I'm not in the weeds on the cost of this stuff, but what I will say is that as I've talked with people, the big benefit of a lot of these industrial IoT changes is your capital equipment costs and your operating costs get flipped. So you don't have a lot of CapEx cost up front with some of these new deployments. You can do very low initial cost, and then it's a recurring cost. It's a monthly, as a service, and that lets you, it's better accounting wise, but it also lets you evaluate the benefits you're getting as you're getting them on down the road. So now you don't have a huge $1 million capital equipment project. You have a $20,000 product or project rather. So proof of concept is a lot easier in that case, and you can monitor it as it goes and make decisions month to month basis or year to year. So I think that is allowing more proof of concept trials for these type of services.
Yeah, that's a great perspective. I think the way that I've heard this kind of communicated by companies that are running these solutions is that you as a technology business, you have to prove your value to your customer every month. Whereas previously you had some lump sum sale, and then they're pretty much stuck with this for until they depreciate it, and then they decide to go,
and then they go to another customer. Yeah, they go to someone else.
Yeah.
So now so we have to prove our worth with these services month to month. That's a great way to put it.
So it sounds like you're a bit more on the technology of the IaaS side of Toshiba, but when it comes to also selling equipment, do you see adoption of new business models there where also the physical equipment is being sold more as a service? And then if you have the predictive maintenance and machine intelligence, you're able to say, it's a little bit of like the jet engine, right? We'll manage it for you, and you pay us, for thrust. Are you seeing much adoption of those models?
We are, and we're seeing that more with the very high value hardware, more so. So something that is, really, really expensive, like a jet engine. We are seeing those business models roll out, but not so much, with less expensive stuff. So maybe, a UPS for a building might still be a single fixed purchase, but, maybe if it's a UPS system for an entire entire area, say several buildings and a big manufacturing plant, that is a viable option, is to run that as a service, and then the service contract is covered by that. So when there's equipment outages or something, that gets dealt with immediately.
Yeah, fascinating. This is, for me, one of the more interesting parts of this whole journey is that you really get to rethink how the businesses operate, how organizations interact with each other.
Right. Yeah.
I remember the IIC. I don't know if this has made progress, but I think they had a test bed between Fraunhofer and, I forget, it was an organization in Korea, which was the I forget the name here, but it was this test bed where you have suppliers around the world, you have visibility into their capabilities, and then you're able to kind of create an online platform where you can say, I want to buy this, and you know exactly who can produce it, who has capacity, who has the right capabilities. Do you remember that one?
I do. It's still active. Actually, it's manufacturing as a service, right? Where you can build a product and go find different manufacturers with different capabilities. So maybe one manufacturer is doing CNC work and another is doing 3D printing work. Yeah, that's very active. Fraunhofer's actually made a demo of that service, and it's the Korea 4.0, Korea Industry 4.0. So trying to map what Germany's doing. But yeah, it's still very active. They just published something recently. If I had the link, I would send it to you. But yeah, very active, very interesting.
Yeah, great. Well, Daniel, thanks for taking time to share with us. I think you're doing great work at Toshiba and also at the IIC. So really appreciate you taking time out of your morning to share your experience with us.
I appreciate it. Thank you very much, Eric.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT1HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@iot1.com.